So today we're going to work with writing each equation in standard form. And if you remember, standard form is an equation of a line that's in this form of ax plus by equals c. And a here has to be a positive whole number. And while b and c can be positive or negative whole numbers. Or if you want to just think of those as being integers. So b and c, positive or negative whole numbers. So let's go ahead and write these in standard form and identify a, b, and c. So 2x over here, that has to be positive. It already is positive. So I'm just going to simply bring over 7y to the left-hand side there by doing the opposite, subtracting 7y. So I have to add 7y. So I get 2x plus 7y equals 4. And there it is in standard form. And then the second part says I have to identify the pieces. So a there is 2. B there is 7, and C there is 4. And then number 12 here, similarly, I've got a positive 3x, which is exactly what I want. So I'm just going to bring this negative 2y on the other side. It's a negative 2y, so I have to do the opposite to bring it over. So I have to add 2y to both sides. So on the left-hand side, I end up getting 3x plus 2y. And on the right-hand side, I get equals 2, negative 2. Identifying the pieces again, a there is 3, b is 2, and c is negative 2. So now we're on to number 13. Notice number 13 does not have an x. So we could just put one in there. I could just go ahead and add one in there. So I could put in a 0x plus 5y minus 9 equals 0. So really it says 0x plus 5y minus 9 equals 0. And now I need to bring that constant over on the other side, so I'm going to do that. So now I have 0x plus 5y equals 9. So again, identifying the pieces here, a is 0, b is 5, and c here is 9. So I have those pieces identified. And then number 14, I'm going to just go ahead and bring the 6y over here on the right-hand side because it's a positive 8x over here, and that's exactly what I want. So I'm going to bring 6y over. I have to do the opposite of the negative there. I have to add. So I get 14 equals 8x plus 6y. And now I'm just going to rewrite it in the correct direction here. So I'm going to put 8x plus 6y here first, and then equals 14. So I just swap these onto the other side. So I move this over, and I move this over on the other side. So now my a value here is 8, my b value here is 6, and my c value here is 14. So again, I have the pieces that I had to identify there, a, b, and c. All right, so that is right in standard form and identifying the pieces. But now we're going to go ahead and we're going to find the x and the y-intercept of the graph of each equation and then graph it. So for this one here, we have to find the x and the y-intercept. So to find the x-intercept, its x-intercept is where it hits right here on this left to right line here. So this is your x-axis right here. We want to know the x-intercept for that. So whenever that happens, your y value on that is always 0. So to find the x-intercept, I can just let y equal 0 and plug it in there. So I can go 0 equals 3x minus 6 and then solve for x there. So add 6 and I get 6 equals 3x, divide by 3, and x equals 2. So my x-intercept just ends up being 2. So now I can plot that. Now if I want to find my y-intercept is on this line right here, this up and down line, your vertical line there. So to find my y-intercept, I can let x equal 0. So now I can take 0 and plug it back up here into the original equation there. So I can go y equals 3 times 0 minus 6. So I really get 0 minus 6, which gives me negative 6. So that ends up being my y-intercept. So I can plot my y-intercept 1, 2, 3, 4, 5, 6. That's where he hits that line there. And then I can just connect my 2 points there, my x-intercept and my y-intercept, and I have the graph. So using your x and your y-intercept, as long as they're different values, we can go ahead and plot those. Let's look at another example there. So y equals negative 2x. Again, to find the x-intercept, I'm going to let y equal 0. So I'm going to take that and plug it in there. So I get 0 equals negative 2x. Got to get the x by itself. Divide by negative 2. And so this is 0, so x ends up being 0 there. So my x-intercept here is right there at 0. Y-intercept, if I plug in 0 now, I'm going to go ahead and plug in 0 for my x. So this time I'm going to plug it in there. So I get y equals negative 2 times 0. So y ends up equaling 0. So both my x and my y-intercept end up being at this same point, and I need another point. So if I want, I could just go ahead and plug in another point, another x value. So maybe I'll pick an x value here of 1. And so I can go ahead and go y equals negative 2 times 1. And negative 2 times 1 there is just negative 2. So I've got a nice little other ordered pair there. I've got 1, negative 2. And I can connect my points. So sometimes the x and the y-intercept end up being exactly the same, so you're going to have to just choose another x value and plug it into your equation there and figure out the y value to go with it is. So let's go on to one more of these here. It says find the x and the y-intercept of the graph of each equation and then graph. We can also use what's known as the cover-up method. And when it's written in this form with the x and the y both there on the same side, that's probably what I would do. So if I want to find my x-intercept there, I can just cover up the y. So if I just cover that up, my I should have said, so my intercept there, my x-intercept there ends up being there at 5. So I'm going to graph x equals 5. And then the same thing if I want to go ahead and find my y-intercept. So this is my x-intercept. And now I'm finding my y-intercept. I can cover up my y this time. So I'm going to cover up my y this time. Sorry, I just did that wrong. Let me do it one more time. I started trying to find my x-intercept again. So I got x plus y equals 5. This time I'm going to cover up the x, and I get y equals 5. It's the same thing as plugging 0 in there because 0 plus y there will also give you 5, so you just get y equals 5. So 1, 2, 3, 4, 5. And there it is graphed. So again, you can use that cover-up methods, and it's easier to do that if both the x and the y are on the same side. I think I've got another one here for you too. So let's try this one doing that same thing. So x-intercept. I'm going to go ahead and cover up the y again. So 2x plus 5y equals 10. So covering that up, I get 2x equals 10. Get rid of the 2, so it's connected by multiplication, so I have to divide both sides by 2, and I get x equals 5. So my x-intercept there is 1, 2, 3, 4, 5. My y-intercept, similarly, I can use my cover-up method for this one as well. So you can just take like your hand or your finger and just cover it up. For me up here, for you to be able to see it, I actually have to scribble it out. So I'm going to go ahead and cover up my x's to find out my y-intercept. So I get 5y equals 10, divide by 5, and y equals 2. So y is 2. And there's the graph. So pretty easy once you can, you have those values just to go ahead and graph with that. So there we conclude the lesson for the rest of your 2-3 notes there.